Hi everyone, David from Aberlink here. In this video we are going to cover software constructions on the Fulcrum. We'll be doing the exercise on the simple demo block. This is the test piece that ships with every Fulcrum, so you can easily follow along on your device. So let's get started. So in this first example we are going to cover a cone plane intersection circle. This is a relatively common construction, and you can imagine in this example where this cone meets this top face produces a circle, and the circle itself is theoretical. It's not actually there, making it almost impossible to measure physically. We can't get verniers on it, we can't use a height gauge. We have to measure both features and use the software to construct the intersection. This is where the Fulcrum really comes into its own. So let's have a look at getting the measurement data. I'm going to be using touch mode in these examples, but if you prefer scanning mode, you can easily use that instead. It's also worth noting I'm not going to be taking the recommended minimum amount of points for each of these features. It's just to make the video a little bit faster and easier to follow along. So let's start by measuring a plane. I'm going to take 4 touch points on the top face. There we go, hit the green tick to accept it. I then need to measure a cone. Now if you don't see the expanded 3D feature toolbar, remember you can click this arrow just in case you don't see the cone like it is on my toolbar. So we select the cone, and I'm going to take 4 points at the top and 4 points at the bottom. And there we go. Press the green tick and both features should now be written into the software where we can construct and dimension anything we want. So we now need to look at constructing a circle between the two features. So to do that, we'll select the circle feature from the toolbar, but rather than measuring points with the stylus as we typically would, we are going to use this construct button. So it's this spanner icon here, and if you hover over it, it says allows this feature to be constructed from existing features. So one click on that button puts the feature into construct mode. So now anything that we select on the screen is going to be used in this construction. So I'm going to click on the plane. I'm then going to click on the cone. A message pops up when constructing circles between cones and planes or any feature with an axis. It's useful as it tells us the angle between two features. If this angle is way out from a perfectly perpendicular 90 degrees, the feature can be somewhat skewed. So it's a useful message. We'll just press OK, and there we go, the construction is complete. So where we would typically see the number of points within the feature in the top left hand of the screen, we see now the letter C. That means the feature is constructed. And if we click the drop down box at the base of the feature, it does highlight what the feature is constructed from. So we can see here constructed from Unit 1 plane, constructed from Unit 2 cone. So if we hit the green tick now, that writes that feature into the software, and the best thing about this is that feature will automatically construct every time this program is run. So as soon as the cone and the plane are measured, this will automatically be created on the screen, so we don't need to construct it every single time, saving a lot of time and hassle. Because it is a feature written into the software as normal, we can dimension it. So 1, 2 left clicks on the feature, move it wherever we want. The third left click drops it down, and there we go. We have precisely measured the intersection circle between the cone and the plane that was previously impossible to do. So that's example 1. In this next example, we are going to construct a gauge sphere so we can work out where it sits inside this cone and work out the height position in relation to the top face. So imagine a valve seal where we have a ball that always sits in the cone. We don't want to have a range of different spheres that we have to look after and calibrate, etc. We just want to be able to construct a theoretically perfect sphere and see where it would sit in the cone. Just like so. So what I'm going to do is we're going to measure the cone and the plane, and then we'll look at getting the construction sphere. So let's get started. So let's start off by getting the plane measured on the top face. There we go. And because the form is more critical in this construction on the cone, I am going to switch to scanning mode. The goal being to get at least 3 different heights, so top, middle and bottom, with more points than the standard touch points would allow. Again, if you can't see cone on the toolbar, just click the arrow that will expand the 3D feature toolbar, select your cone, and because I'm in scanning, I'm going to tap the start of the feature and then start scanning around. I'm going to scan the top diameter, dropping down to the middle, before finally dropping down to the bottom. A pause will finish the scan, and then you should be able to see the 2 features written into the software. Switch the probe off and we can now look to get the construction done. So we're looking to construct a sphere from the cone. It's also worth noting we want the dimension from where the sphere sits in relation to the top face. So that is actually going to be a measurement for the YZ or the XZ view. It doesn't actually matter. So I'm going to right click into space and select XZ. So you can see its side on here. So again, just like anything else that we want to construct, we have to select the feature first. So I'll go to the 3D toolbar and select sphere. I'm then going to hit the construct button. With this, it's a single construction from a cone, so I need to click the cone twice. 1, 2. This tells us the radius. So let's just say, for argument's sake, it was a 25mm sphere that I wanted to seat into the cone. So I would put 12.5 into the sphere radius box. I'll then hit the green tick, and you'll see that tells you exactly where the 25mm gauge sphere would sit. So we hit the green tick to accept it. So just to show you, it's always going to be a perfectly round and formed 25mm sphere. But the important factor here is we can now dimension from the plane. So 1 click on the plane to the sphere. So 1 click on the sphere, and we get the distance of where that seats in relation to the top face. So again, very difficult to do without having the hard gauging. And having the hard gauging means you need to look after them, get them calibrated, etc., and have a wide range of different spheres. So this construction method gives you the ability to construct a range of gauge spheres and see where they would seat within any cone. So that's example 2. In this next example, we're going to create some intersection points between lines. The example that I'm going to cover on the test block here is we're going to measure this line, and this line. And what we're looking to do is work out essentially the shoulder height and depth, or width and depth if you want to call it, between these two. So whilst we can measure the lines, we can't actually measure the points. They are going to be constructed features that we have to use the software to create and then dimension. So let's get those measured. Because we are measuring lines in this example, we need to measure the top plane first. That is because 2D features need a projection plane. They don't know their orientation in space, so they get projected into the plane. Without the plane, we can't measure those features. So let's select the plane first and take 4 points on the top face. And then we can go and measure the lines. There we go. Press the green tick on the last line, and then you should have the features drawn out on the screen ready for constructions. So now we need to construct points where these 2 lines meet, and then again where these 2 lines meet. So just as in the previous exercises, we select the feature first, so we'll select the points. But in this exercise, I'm just going to show you the software can automatically switch to construct mode just by left clicking on features whilst another feature is open. So in this example, I'm not going to select the construct button. I'm just going to pick the two lines by left clicking on them. You'll see that still creates the feature, and you'll see it's constructed via the C in the top left hand corner of the measurement window. So just to go through that again, I'll select the point, but I'm just going to go straight in and left click on this line, then left click on this line, and it will automatically construct that feature. So you can use the construct button if you prefer, but it will automatically go into construct mode by just selecting on features whilst a feature is open. So we'll hit the green tick there, and all we're looking to do now is dimension between the 2 points. It's going to be 2 separate dimensions, so we'll click on this point and click on this point, and then again I can move it to the left hand side and that automatically aligns in Y, or if I move it up to the top it automatically aligns in X. So sit it wherever you want. I'll sit this one down here. It is worth noting when you do have multiple features on top of each other, so if I try to click in the center of the point, the software doesn't know which feature I'm trying to select out of the possible array of features that are close together. So all we need to do is select it from the option box. So I'll click on point and you see that's selected. The same over here, so left click, it doesn't know whether I want the point or unit 3 line or unit 4 line. So I'll just click on unit 6 point and I have those measured. So again I move this wherever I want and then left click to drop it down, and there we go. We have those the shoulder height and the shoulder width aligned in X and aligned in Y. So that's example number 3. In this next example we're going to cover a PCD construction. So PCD, often referred to as bolt hole circle. So PCD stands for pitch circle diameter. We're basically going to measure each one of these individual circles, but then construct a single circle that runs through the center of all 5 circles. That's important as a pattern or a check, so we want to check this diameter is correct, and we can also check the concentricity in relation to the center bore that they are centered around. So let's get those measured. So as with any constructions, we need the measured data written into the software before we can create them. So let's just go ahead and get those done. Just going to scan the plane on the top face. Then scan the center bore. And repeat for each circle. Go, switch the probe off because I'm finished with it, and you should now see on the screen we have the features written into the software. So all we're looking to do here now is draw a circle through the 5 smaller holes. We can then dimension that as well as check the concentricity to the center bore. So again, any constructions we make, we select the feature first, and then you can either start selecting the features or click the construct button. So I'm just going to start left clicking on each one of these features, and you'll see it starts to draw out the circle already. It is important to make sure that all the circles that you are measuring are inside the construct window, otherwise it could skew the reading. And once we're finished, we'll hit the green tick. There we go, we have the circle just like any other feature. It can be dimensioned. So there we go. And again, in this check I want to make sure the center bore and the PCD are concentric, so that is just one click on each. One, there we go, and you can see it's quite far out in relation to that center bore, and that is something that is difficult to check without having the software and the CMM to be able to measure it. So there we go. Whilst we have the PCD circles already measured, we can now cover a different construction type, which is a center line through circles. This is useful in an example like this, as we can check the angle between the PCD holes. So to do this, we select the line feature, and again it's going to be constructed, and there's essentially going to be 5 separate lines. So line, construct between the center bore and this PCD hole. The software does give us the option of center line through point or tangent line. We are going to use center line in this example, and you see that draws the line. We hit the green tick, and if we repeat this process 4 more times, we'll have each center line from the PCD hole to the center bore. So let's just go through and do that now. Hit the green tick, same again. And again, it's worth noting this only needs to be done once. There we go. And we have all the constructions made, so it's very easy to go from line to line and check the angles. It is worth noting that the software, as standard, gives you a 3D angle, so just be wary when you do dimension between 2 lines. This is a 3D angle. If you are looking for a 2D angle, just right click into space before dropping the dimension down and select 2D angle. Because these are projected into the same face, you'll see there's hardly any difference, if any difference at all. But when you are measuring things over different planes, the 3D and 2D angles can be different, so just be wary of that. But as you can see, this gives you the ability to check the angular dimensions on the PCD holes, which would have previously been quite difficult. So that wraps up this construction video using the Fulcrum. It is worth noting I couldn't cover every possible construction that the software can do. There is a wide range. I would recommend, if you come across a construction that wasn't covered in the video, give it a go. It's often very easy and self-explanatory to do. But if you do have any issues, you can contact our help desk and we'd be more than happy to assist.